All right, then we will move on to the last phase that we will discuss in this class, which is late adulthood, which essentially spans from 65 to death. And so we'll first start by talking about physical and cognitive development. Next time we'll talk about social and emotional development. So just like with the previous sections, we'll first talk about physical changes and health issues that occurred during this time. Then we'll talk about some normal changes in cognition, so kind of the changes that you could expect if you live a healthy, normal life. And then we'll also talk about Alzheimer's and dementia, which are obviously more extreme degradations in cognition that can happen during this period. So let's start by talking a little bit about life expectancy. Life expectancy is measured in a number of different ways, and there's kind of different types of life expectancy that we'll talk about in just a minute. But on average, life expectancy has been increasing for, probably centuries. Older adults now represent 15% of the US population, compared with only 4% of older adults in the early 1900s. And that is, of course, due to, advances in medicine and, access to health care, a huge number of different things that have contributed to that increase. Part of the reason that there's been an increase in life expectancy in the US is that there's been a steady decline in infant mortality, and so people are more likely to survive those first few years of life, and if you survive those first few years of life, you're pretty likely to go on and survive for a long time after that. There's also a decrease in adult death rates, so again, that's due to improved nutrition, medical treatment, sanitation, safety, etc. I guess I should back up and say too, the average life expectancy in the US right now is about 78.8. So it's kind of the average you can expect to live to. It's higher for women. So for women it's about 81, whereas for men it's about 76. So there's a pretty large gender discrepancy in life expectancy. That's partly due to men are more likely to suffer from like accidental injuries and death from accidents. But there's also some other health issues. So men tend to have a higher metabolism, and some people have suggested that that leads to earlier deaths for men. Due to aging baby boomers, population of older adults will rise significantly in coming years. It's already rising quite significantly, and there are a huge number of repercussions to that. So the idea that a lot of our population is going to be older. We may touch on those a little bit if we have time, but I don't know if we will. Like I said, women tend to outlive men, so there is a gender difference there. For women, like I said, it's 81. For men, it's 76. So 5-year difference there. So average life expectancy really just refers to, how long can you live before you die? Pretty straightforward number. There's also something though called healthy life expectancy, which is the number of years that you can expect to live in full health without any sort of serious disease or injury. And this number is higher in almost every other industrialized nation than it is in the US. Japan has the highest healthy life expectancy. So in Japan, the healthy life expectancy is 71 for women and 69 for men. So in other words, if you're a woman, you can expect to live to 71 without any real serious disease or injury. For the US, the numbers are 67 for women and 65 for men. So about 4 years less than in Japan. Japan, that's partly due to the fact that they have much lower rates of obesity and heart disease because they have a low-fat diet compared to the US, and so people are less likely to develop diseases because of that. They also have more favorable healthcare policies there than we do in the US. In developing nations, the average life expectancy as well as the healthy life expectancy are reduced quite a bit due to poverty, malnutrition, disease, less access to health care, and also due to armed conflicts. So in most developing nations, the life expectancy is only around like 55. So much, much lower than it is in industrialized nations like the US. And then another measure that's related to life expectancy is what's called the maximum lifespan. So that's basically the proposed limit of how long a particular species can live. So the species-specific biological limit to length of life. The oldest verifiable person, the human being, was about 122 when they died, and so that number of around 125 has been suggested to be probably the maximum lifespan for the human species. And there's some debate about, whether we can increase that number or not. Are there things that we can do medically to sort of advance that number past 120, whatever? And there's suggestions that probably it's more difficult to increase that maximum lifespan compared to the average life expectancy. The increases in average life expectancy are mostly due to advances in diseases and things that happen in like the first 20 years. And so for the most part, if you live, your first 30 years or so, you haven't developed a serious debilitating disease, then you're probably going to live a decently long, healthy life, assuming you're healthy. But once you get up to those upper limits of 120, there's not really any medical interventions that we have that can help increase this maximum lifespan. There's also a question of if we even should we be, investing in trying to lengthening the maximum lifespan? Is it worth it to try to get people to live longer if they're not having a longer healthy life expectancy? So it's important to have a goal for quality of life in addition to, number of years. So there's a lot of debate around whether we can or should try to increase maximum lifespan. All right, so some of the physical changes that take place in late adulthood. You have some changes in the nervous system that come along with aging. You have shrinkage of the brain as a whole, but specific areas are affected more than others. The prefrontal cortex, which is at the front of the brain, it's responsible for executive function, experiences some of the fastest and most extreme losses, as well as the corpus callosum. That's essentially like a web of neurons that connect the two hemispheres to each other, allow them to kind of talk back and forth. You also have extreme losses there. Also the cerebellum, which is associated with balance and coordination. Hippocampus, which is important for memory. You have decreases in those as well. The central nervous system, which is brain and spine, and also the autonomic nervous systems, your sort of peripheral nervous system, become much less efficient. They become slower in addition to these losses of neurons. The loss of neurons accelerates around age 50. By age 80, most people have had about an 8 to 10% reduction in their overall brain volume compared to their earlier years. The brain can compensate for these changes in a number of ways. So you can grow new connections and to some extent new neurons. And most people continue to produce new neurons at about the same rate as they did during middle adulthood and young adulthood. But one of the biggest coping strategies that your brain uses is to kind of call on extra brain regions to do the same work. So, for example, as a young adult, for language processing, you may only use the left hemisphere of your brain, but as you get older, you may have to sort of recruit both left and right hemisphere in order to do the same task. And so it kind of takes more of your brain to accomplish the same task as you get older.